Silence.
Silence.
Hi, everyone. Welcome to this week's or this month's meetup. It's going to be a little bit different format this time. We're going to have a panel discussion. Than normal. I guess we can go around the table and see who we have with us. So we have Hans Christian Flåten from Tieto Evry, and Rustam from Computas, and Kelsey from Google. So maybe we can start with Hans Christian. Introduce yourself.
Yeah. Well, in short, DevOps enthusiast and SRE tech lead for a consultancy agency here in the Nordic called Tieto Evry. So that's basically me.
Yeah, cool. How about you, Rustam?
My name is Rustam. I'm also based in Norway. In Oslo. Work for another consultancy company called Computas. Work a lot with mostly it's Java and mostly it's cloud. So I work quite a bit with Google Cloud and stuff like that. I do talks at different conferences whenever I'm not at work, and I also I'm a GDE, Google Developer Expert for Cloud as well.
Yeah, and the main star of the show, Kelsey. How are you?
I'm good. If people that don't know me, I guess I just consider myself a technologist these days. I'm very interested in platforms, serverless technologies, and just open source in general. So being at a cloud provider, I get to do all of those things.
Cool. Yeah. So today's discussion, everyone can send us question via YouTube chat. We have some nice prizes for the best question of today. So that will be 1 year free JetBrains product. So we'll draw that at the end of the meetup. Yeah. So we haven't really set like a definite set questions for this. So what are you guys up to these days? Is there anything interesting going on?
I don't know.
So I currently on a project where we build a new mobile bank for Norway in Google Cloud and based on Google's Kubernetes engine. So that's been a really cool project there. We actually were able to pull off quite a lot in just 10 months, going from ID to production, and now gradually settling in with more customers and sort of like can't be that they are sort of like they want a little bit more uptime, and we can't really just go around and break stuff all the time. So that's also like a shift in pace there, and that's a new, I wouldn't say new, but that for all projects that's sort of a transition phase there once you hit production and sort of starting to get customers on board.
I would say for me, I spent a lot of my earlier years, maybe the last 3 or 4 years, working and contributing in the Kubernetes space. And what we learned from that, you can kind of see a lot of these blog posts. I guess it's becoming popular now. A lot of people are sharing why they don't use Kubernetes, right? And I love reading those because it really speaks to the user experience around infrastructure. And for the very first time in the cloud, right, we're attaching some of these products to cloud, but there's one missing piece. The trick is you got to run these things yourself. And there's a lot of power to that, but that's not what most people thought of when they think of cloud, right? So when you go to the cloud and you ask for a virtual machine, You don't have to run the hypervisor, right? It's just somewhere it's hidden. You don't know if it's KVM or Zen or VMware. You just don't care because the API is about virtual machines. And when it comes to Kubernetes, we are showing people, hey, here is the hypervisor, and you need to manage the hypervisor and the containers on top of Kubernetes. And it's causing a lot of pain. It's causing a couple of teams to reconsider, is this even worth it? So in the last 2 years, I spent a lot of time in the serverless area. So Cloud Functions on the Google side, and now Cloud Run, which is backed by the open source project Knative. And what we're seeing is that a lot of people do love the container abstraction, right? I built it on my laptop. And what they want to do is say, here, run it for me. That's it, right? I want this version to get traffic, maybe 50% of the traffic. So I think Kubernetes has taught us that there's a lot of patterns that people really, really like. The open source community has given us really nice interfaces for logging, metrics, aka Prometheus. But no one really is that interested in running these things themselves, but they love the option to. So I've been spending a lot of time making sure that we're building the right serverless platforms that take some of the best of Kubernetes, but give you that experience there. You don't have to run it yourself, and you're not locked in. You could take your container and go somewhere else if that ever needs to happen.
I think it's some years since you had this quote where like Kubernetes is a platform for building platform. I guess that's sort of like something among those lines with the whole serverless environment on top.
That's exactly right, because when I step back, in the perfect scenario, wouldn't it be nice if you just went to a cloud provider and they were just a default Kubernetes cluster? No nodes. They just charge you for the pods, and that's it. They take care of the security updates. You just say, is my pod running? Right? I want my pods in these 5 regions. And that's really what most people are after. We want pods in some ways to be treated like virtual machines. And we just want to attach them to load balancers and then move on.
Yeah.
And we were actually thinking a little bit about that part, because we were thinking, well, when we were kind of brainstorming these topics and everything, and we were also thinking about this thing that, well, there was a lot of excitement when Kubernetes came out, when Istio came out, and all the other ones. But then, will it actually be as relevant in a few years, or will it go a bit more into the background and let all these kind of top things on top of it help us to do a better kind of develop better solutions and do stuff like that? And that's one of this really, I mean, it's impossible to kind of know how the future is going to be, but I mean, we can guess. And I guess my guess would be that it probably will go a bit more into the background. And
it will definitely go in the background. There's a couple of ways to look at this. When the cloud started, all the major cloud providers were building their own custom control planes, their own APIs, their own tooling, their own docs, their own way of thinking about things. With the exception of IAM, which most of them are backed by like JOT tokens, right? So there's standards around some of that stuff. But where there are not standards of how do I launch a compute thing, right? Everyone has a different way of doing it. Tools like Terraform try to help give us a way to normalize some of those things, but it will always be different. But if you think now that all the major cloud providers seem to have an Envoy type offering, aka service mesh, and the control plane to configure the network plane is not just this custom VPC or ELB versus GCLB. Now you're saying XDS protocol. So on one hand, we're taking all of these interfaces from the open source, and cloud providers are using that to drive their own control planes. And I think that standardization just took a while. And I think we needed the innovation in the open source to define them, get consensus in the community. And then now it's really safe for a cloud provider to say, even if I have my own custom metric stack, I'll support open telemetry as an input for that stack.
Will that be the end of I wouldn't say end of cloud providers, but if all gets that standardized, then sort of like this hybrid cloud, or not this multi-cloud notion where you can just move your workloads from one cloud provider to another without like just depending on price or availability?
We already can look at an industry to see how that will play out. The internet, right? So even though the internet is roughly standardized, you can go buy a modem and a router from almost anywhere, plug it in, and you may be using a different ISP than I am, but it doesn't mean the ISP will go away, but we stop talking about the ISP. And I think that is where long-term, you're right, because as a developer, wouldn't it be just nice to say, who can run this for the best price? Run it for me and give me an IP back, right? That's all you really care about. No one cares about this provider versus this provider, because that's not how networking works. We don't care who owns a particular IP block. Our browser just calls the IP and it does its thing.
Yeah. Probably just push sort of like the envelope, push the sort of where you have to be innovative just to another level. Like, who can provide the best computer vision API, or who can provide that type of service, and not caring too much where you're actually running your work.
Now you're talking about solutions, right? And I think that's right now, if I were to think about where we are with cloud, we're building like game engines, and you can build any game you want as long as you know how to program on this game engine. And there's a lot of people in the world that just want to play games. They just want to play Borderlands or whatever. They don't want to build a game from scratch. And I think the solutions, like you just mentioned, vision APIs, those are solutions where you just call via API call. Hey, here's my image. Tell me what's in there, and then I can go do the rest.
So, but wouldn't there be an incentive for the bigger cloud providers to prevent this level of abstraction?
So the nice thing about competition is that, so let's talk about like, remember when Netscape was like the #1 browser? Netscape, it's like everything's Netscape. And then you get Internet Explorer, right? And Internet Explorer is everywhere because everyone's using Windows. And then you have Firefox. And I remember, I don't know if everyone's old enough to remember, but there used to be this map that Firefox used to show. This percentage of the world is now moving away from IE. There's like a campaign.
I remember that.
Remember? And it was like, yes, Firefox is winning. I don't know why we were cheering, but everyone was very happy that Firefox was winning, even though we were going to get nothing from it.
I guess it's the underdog thing, right?
It's exactly where I was going. The underdog. So when Chrome comes out, it says we're not doing Flash, we're not doing ActiveX. We're just going to focus on HTML5, and we're going to do standardization. And we believe if we do it right, all of this innovation that's happening with HTML5, CSS, we're going to make sure that Chrome and JavaScript, that Chrome is going to support them all, so there's no delay in innovation. And then what happens is you grow to be this kind of, highly used web browser. And guess what? Now Microsoft is using Chrome with Edge, and now it's this kind of open platform. The cloud is going to be the same way. Google could be considered the underdog today. And guess what we're doing? The very similar approach. We're giving people open APIs. We're saying this is, and honestly, sometimes open is even better than the thing that's proprietary. And when that happens, you almost kind of put a lot of pressure on the provider to say your customer is asking for Prometheus style endpoints. Your customer is asking for Kubernetes style APIs, and you have to provide them. And then open wins. And now you have to compete on uptime, price, reliability. And then, like I think you mentioned earlier, Hans, that things I can't do on my own, then we can start paying for those.
Yeah, it's quite amazing that you can now get the more or less exact same Kubernetes API from all of the different cloud providers, and you sort of like, it's Kubernetes. It's the API of Kubernetes. Doesn't matter if it's sort of like if it's the actual Kubernetes implementation or it's using etcd or some other storing. So that's just implementation details, but you get the same API. We do have a lot of customers here in Norway and companies in Norway sort of like feeling that they have been sort of like been in this sort of vendor lock-in proprietary APIs and sort of middleware servers and whatnot that are showing sort of signs that sort of not necessarily doesn't need to be, or it's not particular to Kubernetes or so, but it's particular to these type of open standards and being able to rely on that and be able to sort of swap out one provider for another.
And we talk about vendor lock-in a lot, and from my personal experience, I don't think most people care about vendor lock-in too much. It's when you get locked out. So if I have a proprietary vendor, maybe they get a little lazy because they're making a lot of money. They're like, hey, we have a product that's pretty good. We just kind of do bug fixes here and there. And then another industry kicks up, and now they're doing all of this innovation, and there's a new API. And for most customers that I see, the first thing they do is turn to their existing vendor and say, are you going to support that? Are you going to allow me to do machine learning? Are you going to allow me to do mobile? And when the answer is no, now you start to have all these feelings of being locked out of those things versus being locked in. Because if I had a vendor and they keep giving me all the stuff that I'm seeing in open source, why would I actually leave? It's like, well, you're bringing me all the things that I need. I don't feel like I'm being locked out of these open things. So I can keep doing business with you. It's just when you don't, that's when you start to have a bad feeling towards your provider, saying, you know what, you are causing me to miss out on all the good stuff. I got to get out of here.
That's actually a very good point. Yeah, it's yep.
Yeah, and it's typically during these types of recessions that we are sort of seeing, sort of with the COVID-19, that we typically see that there's, well, maybe it's good to have a little bit more competition on who can provide me this type of service, and sort of having open source products. Then you're sort of like, you're more free to choose who are offering the service that you are, the best service that you are willing to pay for.
And I think we'll see a bit more and more of that in the future. So instead of just picking a cloud, you'll end up picking a service or a like specific thing and just go for that. May it be platform as a service or software as a service or whatever that would be. But then you'll just kind of pick one, and then just, you know, you kind of pick and choose and build your own. Well, if you use the game analogy, you build your own game, but just with the different pieces of puzzle.
You make a very important point, because when you go into people's data centers, the switch could be made by Cisco, the servers could be made by HP, some other person makes the network cables and the power PDUs, but no one ever says multi-vendor, right? We're going for a multi-vendor strategy, and the reason why we don't say that in the data center is because in the cloud, we're typically separated by physical buildings where network latency comes into play. And that's the only reason why we say multi-cloud, because we know that if I pick this vendor for my compute and this vendor for my data, there's going to be such big perceived latency that it's forcing me to say multi-cloud. And I think you're right in terms of like, Let's Encrypt is a good idea, a good example. Now you have a certificate authority where latency is not a big deal. I get the certificate every 3 months. I bring in the certificate and I can cache it locally. A lot of people, regardless of the cloud provider they pick, they just use Let's Encrypt for all of the certificate management, right? And that's definitely exactly what you mean by, I just want a service. And as long as latency doesn't get in my way, I'm not going to say multi-cloud because I'm using Let's Encrypt. I just use what I need.
Yeah. You're using Let's Encrypt, right? Yeah. Well,
so
do we have any question?
But like in this type of world, what would be the next level of abstraction that you would build on top of Kubernetes and all the hybrid cloud? So like that Kubernetes will eventually go further down the stack, and you wouldn't interact with it at all.
I think Knative is a pretty good pointer of where things are going, like Kelsey mentioned already. I mean, if you look at what's behind it, you have all these containers, you have Kubernetes, you have Istio, you have all the other things just put together, because, I mean, at some point they're getting so complex to manage that you would like to have some kind of framework to manage that. And on top of that, then you build and you simplify and simplify and simplify. Now I don't have to think about pods. Now I don't have to think about the networking or things like that. And then it kind of magically happens.
So let's answer this question, then let's jump into some of the questions in the live comments, because I see some really good questions that I would love to answer.
Yeah.
To your point, in the Kubernetes world, we're starting to get to the point now about, it's more about automation than it is abstraction. And the reason why I'm saying this is that the pod did a really good job of encapsulating a workload. How the pod is managed, whether you take a deployment controller where you run a thing for a long time, or a job, or a stateful set. But the pod is the core element that we like to describe our workloads, right? And to me, that's the thing the kubelet and the machine ultimately understand, and it takes instructions from these other things. And I look at all the other things, whether the scheduler is an automated way of placing workloads based on things we know about the environment. And then all these CRDs, and if you look at most of these things, it's really about integration. Get my certificates from here, put it in the secret so that this thing can use it. Or if I want to do chargeback, start charging based when the pod starts, and then stop charging when it goes away. And then everything else is morely configuration. I have something like Envoy in my data plane, and I can tell it what to do. So now you get Service Mesh or Istio. So I think with the next 5 years in the Kubernetes, or even 10 years by that way, will be more automation, right? It's going to be like the period we saw with Linux and config management, Puppet, Chef, Ansible. These are just different ways of configuring Linux. We didn't get any new abstractions. So I think for the Kubernetes world, you're going to have a lot of people doing lots of integration, lots of automation, and the abstractions, I think, going forward. You can build serverless platforms on top of Kubernetes, but if you tell someone that they got to run and install Kubernetes first, it doesn't feel like serverless anymore because you're asking me to go set up a bunch of servers. So I don't know if that's where we're going to see all of the innovation, but I believe the APIs will be compatible and they will run on top of Kubernetes.
Yeah, we sort of have to get there, because what I'm seeing today is that a lot of companies are really failing when they sort of adopt these types of technologies, and that sort of doesn't have to be Kubernetes, but lots of other there. And it's just too much to configure, too advanced, and like, oh, I'm used to dealing with virtual machines. I just treat this as a virtual machine then.
I'm going to jump into a question. You don't mind? I'm going to pull it.
No. Yeah.
In your famous Tetris showdown, how do you see Kubernetes as a brick? And how do you think it will be part of a layer that disappears? Just infrastructure the developer needs, not to care about. So this kind of piggybacks on what we were just talking about. When I was coming up with the, just using the Tetris analogy, it was really around the scheduler. And the fact that when we look at the YAML files, the analogy there was the YAML files is what creates the shapes, the bricks, right? You can have a square, you can have a long piece, you can have the different types of shapes that you see. And that's, for a lot of people, they'd never given their workload shape, right? So I need a big VM, and they copy the app over there. But they didn't really know what the shape was, so they didn't know how to fit 2 or 3 different apps on the machine in a safe way that would really optimize their utilization. So the whole Tetris analogy is more about bin packing. And the abstraction there was also the container image. So the pieces that fall in Tetris don't say, this is a Ruby piece, this is Python piece. They're just all pieces that need different resources. So that's where that analogy is. Now, let's say we would have turned Kubernetes itself into the brick. Now you start to get something slightly different, because Kubernetes itself is the thing that represents the Tetris board, right? It's the finite set of resources. So Kubernetes is the big thing of saying, this is all the room you have to stack your pieces. So you can imagine trying to play 3 games of Tetris at one time, so multi-regions. And if you think about a multi-region setup, it's just that your Kubernetes cluster gets a little bit bigger. And at that point, now the Kubernetes is the big Tetris board, and you can fit more pods in there. But maybe you put columns to say, hey, once a pod moves over here, it has to be placed in this section, this region of the game board. So if Kubernetes were to disappear, we wouldn't even have to play the game. We would just say, here's a piece, and there's no game for me to win, because you are the one responsible for scaling this layer up and down so that I have the illusion that I can keep throwing pieces and I don't have to play the game. Today, we're asking people to play the game. So if Kubernetes were to disappear, we would just say, here's my pod. Someone, somewhere, keep it running, and I don't know how you do it.
Yeah, it sort of reminds me, I saw this sort of demo where they implemented Game of Life in Game of Life itself. You just zoomed out, and then suddenly you just saw the same, just in a much, much larger sort of implemented in itself, sort of like just building on top there.
I'm going to take a couple more if you don't mind. Can you use Kotlin VM on serverless? What about startup times on the VM? What native options are available? So this is a good discussion, because Lambda really takes a whole different approach, right? They've really leaned into this whole functions as a service. And the contract with the function is, you don't write a server, you write a client that connects to their serving infrastructure. And maybe you block until you get a request, and they can freeze your process. So they decide. So ideally in that world, if you have a lot of cold starts, meaning in order for them to give you a good price, they have to shut it down, that VM cost of the JVM is going to be expensive, right? JVM is optimized for like long running. But when you have that quick start, You may be paying the startup cost maybe even longer than the execution of the actual thing you're trying to do. So whether it's Kotlin or Java or Clojure or whatever you're using, it's the JVM tax that's a bit expensive. So let's talk about a different form of serverless, because I don't think serverless is restricted to functions as a service only. When you start to think about Cloud Run or Heroku or Azure, they have their kind of container instances. In that world, you're kind of back. So one thing is we have a concept called minimum instances, and Azure does too. And what minimum instances says is, okay, I'm still going to charge you for the request. So think about Cloud Run in a world where I start you up, and then I'm going to maybe throttle the CPU from underneath you. So you had plenty of time to start up. You're kind of warm, and now I can just take and throttle all of your resources, and you can now run the JVM and pay the startup tax once. And maybe I keep you around for a long time until there's a new version, and then I swap you out. So I've always pushed that scaling to zero to me is an implementation detail. We're only doing that to get to a very good price point for you. But ideally, the way we're trying to do this with Cloud Run is, what if I just freeze or throttle your workload and not have to pay that startup tax every time? So that's an interesting thing to think about.
Yeah. Were there more questions?
I'll do one more question, then we can jump back to the discussion. Here's one. It's called, our service is built on GCP using Google App Engine Standard and Go, but using Docker for development is super efficient. Are there really good reasons to move to Kubernetes except becoming cloud agnostic? So App Engine is great because that's that whole platform as a service. It's not just that you can run a container or just run an app on App Engine. It's the fact that it has libraries for almost anything, for storing data, for doing traffic management. A lot of people in the App Engine world are just not dealing with the stuff we're talking about at all. They just run their application. And what we've tried to do, so you got to remember, the App Engine team and a lot of people from the App Engine team also built Cloud Run. The infrastructure underneath is very similar, same as for Cloud Functions. So what we wanted to do is say, hey, imagine a world where you can run any custom runtime that you want. We don't care if it's Haskell. We don't care what the language is. And we're going to make the contract, instead of source code, let's make it the container and allow people to use any library they want. And that's what we're trying to do. So if you look at Cloud Run today, you have traffic management. Now you can deploy multiple versions of your app as revisions using the Knative specification. So App Engine is really focused on, or Cloud Run is making sure that we have an open source, portable platform as a service, taking a lot what we learned from App Engine, but not necessarily locking you into the App Engine library. So instead of the App Engine tracing, we'll use open telemetry libraries. So the nice thing about that now is that I can take that container from Cloud Run and run it in Kubernetes or just run it in Docker. That's the goal. But I'll be honest with you. If App Engine is working for you, then ignore all this other stuff. Just don't even worry about it right now. Like, you're okay. Just keep doing App Engine. Maybe when Cloud Run has all the features that you need that you're using from App Engine, maybe look at Cloud Run to get a little bit more flexibility and have a kind of future-proofing model. But just going to Kubernetes means you're going to have to re-implement a lot of things yourself, and you're going to be mad at me if I told you to do that.
That is true. And another thing is just actually probably would be asking kind of question back and asking, like, is there anything that you're missing in the whole setup that you have? I mean, is there anything that you would like to have but cannot because of whatever you're running it on now? I mean, does it really worth spending time actually porting it and stuff like that? So I think that's also a good question to ask yourself when doing this stuff like that. Because, I mean, you can always do that because it's cool and trendy and everybody talks about that. But when it's the only reason, then maybe you should not do that kind of things like that.
I'll let people on the secret. So most of the things I'm building these days is 100% on Cloud Run. And I will test to make sure that my stuff runs on Kubernetes. But most things I'm doing, I don't use a lot of sidecars anymore because there's so many good structured libraries for logging data. There's really good APIs now for sending metrics and all these things. I'm using now OPA, Open Policy Agent, to do authorization. Instead of using a sidecar, I just import the Go library and I just do my authorization there. And when it comes to storing data, Either I'm using something like Spanner or Cloud SQL, or I'm just putting things in Google Cloud Storage, and that's my file system. So I've really changed the way I think about building an application, and I don't feel like I'm being locked in either. I feel like if I take that container, I can run it from my laptop. Of course, I have to hit the Google, metadata servers and all of these things, but it definitely still works. So I don't know. I think Kubernetes was a good way to push me towards structured modeling my application, but now every platform seems to be available to me.
Yeah, we have had a lot of sort of companies and teams sort of like starting out sort of deploying Kubernetes on their own data center and then gradually moving that workload to the cloud as containers, sort of as a migration strategy there.
I love that approach, right? Because anytime your team can sit down, it's like what CI/CD does. Everyone thinks CI/CD is this great thing. Not really. But the nice thing about CI/CD is you really need to sit down and understand your system to create all the build steps. And anytime a team does it, they just feel more confident. It's like, wow, we can repeatedly deploy this thing. And that just makes people feel good. I see another question here. I want to answer it because it comes up a lot.
Yeah.
Regarding config management, JDKS, Q, Pulumi, or others. And this is where I talk a lot about infrastructure as data. And everyone's like, Kelsey, what's the difference between infrastructure as data and infrastructure as code? So Puppet, Chef, Ansible, I would probably put Pulumi and Terraform. Those are all infrastructure as code, right? They have fully fleshed and very flexible DSLs. You can write in, what looks like to be a complete programming language. In the case of Chef, it is actually Ruby. And then those things typically call APIs. So if you want to create a database, they will call some API to create a database. Now, let's say you go from Chef to Terraform. You have to start over. You have to take all your Chef code, and now you got to write stuff in HCL. So that HCL can now underneath call the same APIs. Now, when you do infrastructure as data, the Kubernetes way, there's still infrastructure as code, which is in the control loops. People call them CRDs or operators, but we force ourselves to put everything in that binary and deploy it as a container and version it. And then the only way we can interact with it is we can't call code. We have to say, hey, what is the spec for interacting with that particular control loop? I know that it's going to do full lifecycle management, promise theory, and I'm going to ask my definition in the front. So if I want a database, I will give it parameters, and there's static YAML. And everyone says, oh, I'm writing too much YAML. My keyboard is breaking all of this YAML. My computer is getting hot. VS Code can't keep up with all the YAML. How do I deal with it? And you start thinking config management. And the way I want people to think about config management is, now that we have a very nice structured configuration language, right? Very static, very easy to read. And it reminds me of like assembly code, right? Intel instruction set or ARM instruction set. Once you have these instruction sets, now we can have Ruby, Python, Golang, C++, because they all have a target. So when you look at Kubernetes YAML files, you have to look at them as a target. And then you can pick Pulumi to generate your YAML files, and then check in those YAML files, and you start to create a data pipeline. Why? Because you may start with Helm, Pulumi, or Terraform, and they may create the initial structure. But then when you deploy that structure to Kubernetes, there's going to be a webhook that will take that structure, and it doesn't need to know HCL. It doesn't need to know Ruby. It just needs to know the structure. And then it can add or remove things to the structure. And now you're building a data pipeline. So I always encourage people, it's okay to pick a configuration management tool. But remember, it should only be generating data that can then be introduced as part of a pipeline, so you can switch tools or use policy engines like OPA to decide if that resource can live in Kubernetes or not.
Yeah. I guess we can plug our next week's meetup at GGG Cloud Oslo. We're going to talk about Terraform and Pulumi.
Yeah, I'm looking forward to that.
Yeah, but sort of like, so I really feel that we haven't been in this place before where we can actually treat the configuration as data. Sort of, if you can, it doesn't matter if it's the Kubernetes API or what it's something that's structurally, and you can sort of parse that, and you can just, something else can come along and just consume that configuration.
This will be the big changing moment. So what people have to realize is, even if Kubernetes were to go away, I believe this style of managing infrastructure will remain. Just like when we think about the web browser hitting a web server. And from that big advancement, we took out HTTP. And now we have REST, gRPC. We have all these other technologies built on that middle layer. And I think the Kubernetes configuration model, that Kubernetes API server, that whole way of thinking about dealing with state and distributed systems, that part will remain, CRDs, if you will. I know we are almost out of time. I'm going to answer a few more questions. Looks like people have a couple of other questions, and I know people love when we answer the viewers' questions. So let's go there.
Yeah, definitely. Yeah, definitely.
I've been following the development of Crustlet, a WebAssembly runtime for Kubernetes. I see this as a way to make Kubernetes language agnostic. How are your thoughts about these emerging technologies? And so this is one area where I look at it as Kubernetes API is very well understood. Tools like K3S that say, hey, we can squash down all of those microservices into one binary to make it easy to deploy for smaller installs. Great. That's just another implementation. Do you have to use etcd? No, you can use SQLite. So for the kubelet written in Golang today, all it does is say, hey, Kubernetes, give me the workload, and then make sure that it runs under some container runtime, CNI, synchronized secrets, etc., maybe pass back metrics. If you really want to write that in a different language, have fun. Is there a lot of value in doing that? I have no idea. In terms of thinking that I want to just give Kubernetes like random languages, now we're going to get in trouble. If we go back to deploying Python and war files and jars versus byte, now we're kind of going, I think we would be going backwards, right? Because really the contract today is system calls. Package your app with all of its dependencies, and it should just run making system calls with something that looks like a kernel. If you start doing all of this stuff where it's like, hey, kubelet, run some JavaScript in the kubelet, man, buddy, this might be a problem. So we should be careful. But you know how it works, man. If it's cool, we're gonna do it. Hey, WebAssembly kubelet, okay. Now we're gonna have a Chrome browser on every machine running JavaScript instead of containers. Hey, let's run it. So next question. Given startup-based billing in the cloud, do you think we will see more languages following in the steps of Go and compile static binaries such as Growl and native? Oh, yes. I love this question. I remember doing Go for the first time. Previously, I used to write a lot of Python, even contributed to some core Python stuff, Ruby, all of these languages. I was like, oh, and then we had tools like RVM. So you have to have this version of Ruby with gems, so it doesn't get all broken. And then RVM takes over your bash shell. So now bash is broken, whatever. So then Docker said, hey, maybe all those dynamic runtimes were not the best idea, because Docker in many ways creates a static binary. If you think about it, takes everything and makes this executable blob. It's a tarball, but just run with the analogy. But then when you touch Go for the first time, you built everything and you say, go build. And if you do the static flags, you can get the static binary. And if you've been a system administrator or developer before that had to deal with setting up dependencies, when you can SCP over the binary to a clean system and it works, oh my God, you just run around the room like, oh my God, it works. It works every time, right? You have a different version of Go and it just works. You're just like, oh my God, now my life is different. So when I look at the Java community, I used to manage Java stuff a lot. I have JBoss. I have some class paths. I have 7,000 class path. Try to share the class path with another thing. And then you have all these scripts that try to link all the class path with environment variables. And you're like, this is a nightmare. This is why most people are scared to upgrade Java, because trying to run 2 Java on one system, forget about it. But I do think there's been a spec in the Java world to say, hey, maybe we can create static executables. Same thing for .NET. And the truth is, most of this has always been possible, but people had this perceived benefit of being able to have all the libraries once to make it easier to upgrade. And that may still be true, but I think we have much better build systems now that if one of my dependencies change, I can just go recompile all of my binaries and then just roll them out. So this is going to be super interesting. That's the last question that I saw there that I think I wanted to answer. But yeah, these are really great questions. And I think this is definitely the way going forward. We have proven container images that static binaries might be slightly easier to manage, especially if we can start doing governance on our dependencies. like the work GitHub is doing. You import libraries, and now you have things like Go modules and other things like POM files. I can tell you have some dependencies that need to be updated, and just getting that notification that can trigger a rebuild and an upgrade of your application. So now that we're there, I think static binaries will really, really, really work really well going forward.
Yeah. With regarding dependencies, I still think we are a little bit in this middle ground. We're like, oh, the system administrator. Now, I don't have them dependencies on my machine. They're developers' problem now, and their developers are like, oh, I'm not used to dealing with updating these OpenSSL or whatever. So,
very true.
Yeah. One thing, Hans Christian, you're a team leader of a lot of for the DevOps team here in Bergen for your company. I think there are a lot of people that kind of try to figure out a good way of getting into Kubernetes and how to get started with Kubernetes. And you have your Kubernetes the hard way on GitHub. So what's your advice for getting started and getting into this whole world with building all this complex infrastructure?
Well, if I could just like alter your sort of question a little bit, Øyvind, that let's just face it, we are like all males here. How do we also like enable a little bit more underprivileged groups in society also to take a part of this? I believe that's a huge issue for us as well. So,
yeah. So when people ask me why do I keep the Kubernetes the hard way maintained, it takes me so many hours to go through all the config options, test everything, make sure that it all works. Is because for me personally, when I was getting into tech, it was the access to information that made this possible. I didn't go to college. I didn't have a CS background. I didn't get a computer when I was 5 years old. None of those things. I didn't get into these things until really after high school. So for me, it was the access to the fact that I could go to a bookstore and pay $20, grab a book and read that book 20 times to really learn this stuff. And now that we have tools like GitHub where I can actually share my learnings with people, programs like this, we're just making all of this stuff accessible. We're not asking people if they're qualified before they can start learning. We're not asking them to pay money in many cases before they can start learning. And I think that is really the key. So whether Kubernetes is the right tool or not, even just going through those kind of documentations and getting experience, it attracts so many people to our field and enables them to succeed. And I've met a lot of people who said, hey, I went to Kubernetes the hard way. I built a home cluster and I went for an interview, and they were like so far ahead of even people who were just looking at it and never really touched it, that they were able to get a job. That's very, very empowering to people.
Yeah, definitely. Yeah, I think that's one of the really, really nice advantages, especially with open source, that you can just like download it, compile it if it needs to, and then just start getting your hands dirty and starting to use it.
I'll answer the question more concretely. Like, so let's say you want to get into Kubernetes. You really need to understand what you're signing up for here. If you go with a fully managed offering like Google Container Engine, you click the button, bam. You're going to get a nice curated distribution of Kubernetes. We kind of know what versions go together. You still need to think about channels, right? Because if you start with Kubernetes 1.14 and you install a bunch of third-party extensions, you found some cool things on GitHub, the power of open source, and you put it in there. Thing is, not everyone's updating the controllers for 1.16. So if you just upgrade, even fully managed, right? You're not installing Kubernetes, fully managed, and you click upgrade, or you turn on auto upgrades, and you go from 1.14 to 1.16, all of your third-party things may break if they're not thinking about forward and backwards compatibility in those controllers. And there's not a lot the cloud provider can do to help because they have no idea what API calls that those things are making. And then the other extreme is people are saying, I'm just going to roll my own cluster. They say, hey, Kelsey, I read Kubernetes the hard way 3 times. I'm ready. I say, I don't know if you're ready because I'm not ready. And then they hire 50 people and they're building Kubernetes clusters full time. And then the company's like, why are you wanting to manage kubelet? You're compiling Docker from source. What the hell are you doing? Why are you doing this? So you have to ask yourself, you have to be really understanding what you're signing up for. Do you really want to be a cluster administrator? And if you are going to be a cluster administrator, then your team is going to expect that you can troubleshoot when the kubelet breaks. You can troubleshoot when CNI is not working, when IPs get stuck, or you haven't done a good job managing your memory, and you see all the containers get evicted from the nodes. You're like, hey, why is everything being rescheduled? And you have to just make sure you know what you're asking for. It's just like saying I'm going to run my own VMware cluster. Hey, you got to know what you're signing up for. So that's the way I would get into it. Pragmatically, start with a fully managed. Nothing's wrong with running Minikube on your laptop to learn the API, but that is not a good representation of a multi-node cluster with a separate control plane.
Yeah, definitely.
Yeah. I think we are more or less out of time now. Was there any more questions on YouTube?
Looks like
So
I
So
don't
we
see
have
any.
actually we have 2 JetBrains gift certificates to give away. So maybe Kelsey, which question do you think was the most interesting one?
Oh, so don't blame me, but I'll definitely pick. I think one question I like is, let me go back to it.
I think this is enough prize for the first prize. Being picked first, the best question for Kelsey.
Yeah, I think the App Engine versus Kubernetes one is a really good question because it really digs into the trade-offs there. So let's go with the GCP versus App Engine. I think it's Harvard Nord. He gets, that's the first one. And of course, the next one's got to be the famous Tetris breakdown. Because I'm really proud of that demo is the second one.
I thought you would say that.
Yeah, but this was really inspiring conversation.
Yeah, definitely.
And I hope you will come and join us for another conversation at a later point.
Yeah, I like this format. Very organic. It's just like the discussion that you have at a conference, right? Where you leave the sessions and you just go to the hallway and everyone just starts talking to each other. I love those, and I think we've been able to capture that digitally today. So thank you for having me.
Yeah, thank you, Kelsey.
Thank you for doing this.
Yeah. All right. So I'll reach out to the winners, and we'll send you the stuff by email.
Awesome. Later.
All right.
Bye.
See you guys.
All right. See you. Bye-bye.